questions from the benchmark review that the district actually gave us to help you review for the benchmark. So normally when they make the review, they are actually able to see the questions where I'm not able to see the questions. So normally it's more aligned to the actual test than I could create myself, which is nice. They are open-ended though. The test will be on a computer through Performance Matters, which is new to you guys and new to us. It's a new platform they're using to like look at all the data. I'm assuming that there'll be a lot of like multiple choice or like fill in the blank or maybe some drop downs as well. It won't be open-ended like this. That doesn't make much sense. So we are going to be open-ended with this and just kind of cover all the bases, but I don't know specifically what they would ask you or what the multiple choice would look like. So for 8, it says describe the transformation from triangle ABC to ABC prime. So ABC right here is the original, the pre-image, and then ABC prime with a little mark is the image after the transformation. So keep that in mind, and it looks like a reflection. So reflection, some of you probably have that already. We're going to get more specific with it though. It is reflecting over this line here. We can see that. And that line is the x-axis. By the way, the reason why this is printed so light is I use the classroom printer and I've had the toner replaced and it still prints light. So I don't know what's going on. So reflection over x-axis is what's happening. Yes, Bruno. See. Not like on the daily. I'm familiar with him. Thanks, Bruno. Okay. So reflection over the x-axis. The other thing I'm going to go over is the points. On the answer key for this, she also talks about how the points change. So for point A right here, we're going to choose a corresponding point, A and A prime. A is at 1, 1, and A prime is at 1, negative 1. So as you know, there is like a coordinate rule for reflecting on the x-axis. Reflection, there's coordinate rules. Now, remembering the coordinate rules on the benchmark, like we aren't allowed to have the rules up on the board or anything. So you may not remember all the rules, but you can always figure them out if there's a picture like this. So A would be at x, y, oh, I didn't mean to do that, x, y, and then A prime, just looking at these points, x is staying the same, and then y is changing sign. So x stays the same, and then y changes signs. And then this would be like the coordinate rule. If you needed to, or if it was asking about it, you could do that. Okay, the next one, describe the transformation from A to B. That order is important. It tells you A to B. When you rotate, a positive rotation is counterclockwise, so it's rotating like that. Just visually, it's like one turn would be 90 degrees, 2 turns is 180 degrees. So I would say a rotation of 180 degrees, as you can see. The other thing is you can use the concept if you weren't quite sure. What you can do is choose a corresponding point on each triangle. So I'm going to choose this point corresponds with this one. And then for a rotation, if we were to draw a line from this point to the origin, and then a line from the origin to the other point, we should have whatever angle rotation it is. So this is a 180 degree straight angle, so therefore this is a 180 degree rotation. Also, this distance here from the origin is the same for both shapes, so this distance right here should match this distance right here. So if you needed to plot points or if you needed to like draw this in some way, you can use that concept to do it. And then you can use all the corresponding points. So I would say this point corresponds with this one. It should be a 180 degree angle through the origin, and that distance should be the same in each direction. So that distance there, you can use your sketch paper to measure and get that point wherever it's supposed to be. And then as far as the coordinates go, we're going to choose a corresponding point. I'm going to choose this spot, this point I've been working with. So on triangle A, it's at 3, 1. And then on triangle B, it's at -3, -1. So 180-degree rotation. A starts at x, y, and then it becomes the opposite sign, -x, -y. And that would be the rule. I'm going to zoom in a little bit. I should have zoomed in a little bit. Okay. Then number 10 is a proof. Proofs are scary sometimes. I remember them being scary when I was in school too. But once you realize that the same situations come up over and over, they get less daunting. And that's what happens in this one here. It's a lot of like very familiar situations that are easy to figure out. So it starts with a given, of course, it says given, and then all you would need to do is put this right in that space. Angle 2 is congruent to angle 3. And then in your picture, you would mark that as well. 2 is equal to angle 3. You could either lightly write on the computer screen, or you could use the transitive property, or you could write it on a piece of paper and draw it out. But writing on it will help you determine what's going on. Then the next thing it says vertical angle theorem. So I have a couple situations vertical angles. I have vertical angles here and vertical angles here, but I noticed 3 and 4 are in the next step. So it's probably talking about 2 and 1. So angle 1 is congruent to angle 2 because they're vertical angles. And then the next step, it says angle 3 is equal to angle 4. Those are vertical angles, so those are equal because of vertical angle theorem. And then last but not least, it says that 1 is equal to 4. Well, since 2 is equal to 3 and 2 is equal to 1, 3 is equal to 4, it's all transitive. It's transitive. Transitive property. I feel like they could use one more step in there. Usually they do 2 is equal to 3, 1 is equal to 2, so therefore 1 is equal to 3. And then they could say 3 is equal to 4, and then 1 is equal to 4, but whatever. It is what it is. And then proofs, it's usually drop down or multiple choice. Okay, so put your name on it, turn it in.